Section 6.4 is called Sum and Difference Identities. We're going to do this in 2 days. So basically, these are identities right here. We've talked about identities before. They're statements which are true for all angles except for non-permissible values. So the A and the B in this case stand for different angles. You can see why it's called sum and difference, because in the first identity, for example, the sine of two angles summed together, so in other words adding together angle A and B and then taking the sine of that value, is exactly the same as taking sine of the first angle, cosine of the second angle, plus cosine of the first angle times sine of the second angle. Wow. And then there's all these different identities, 2 for sine, 2 for cos, and it depends on whether you're adding the angles, in which case it's a sum identity, or subtracting the angles, in which case it's a difference identity. Okay, now what do we do with these things? Well, there's all sorts of different questions. One sort of thing that you commonly have to do is you have to find the exact value, so we're not going to use our calculator here and find a decimal. We want an exact answer of tan 15. But if you think about it, we've never, that's not one of the special angles, tan 15. But what you can do is you can get that exact, you can get that angle, 15 degrees, by taking 2 of the angles we do know exactly. So what sort of angles do we know exactly? Which sort of angles are special angles? 0 degrees is a special angle, 30 degrees, these are all degrees. 45 degrees, 60 degrees, right? We know all these, 90 degrees, and then in the second quadrant, maybe I'll just go a little bit further, there's 120 degrees, there's 135 degrees and 150 degrees, and I suppose 180 degrees takes. These are all the special angles between 0 degrees and 180 degrees. If you don't know how I'm doing that, look at the unit circle, and there they all are. Okay, if we want to get tan 15, do you see that tan 15 is exactly the same as tan of 45 degrees take away 30 degrees, right? 15 is the same as 45 take away 30. So now what we can do is we can use one of our identities. Which identity can we use? Well, this is a tan A minus B. We're subtracting 2 angles. Oh, it's this one right here. So we can plug in everywhere. Remember now, maybe I wouldn't expect you to write this down, but just so you don't make any mistakes, your A value is equal to 45 degrees, and your B value is equal to, not negative 30, it's take away B, so the B value is 30 degrees. And all you're going to do is you're going to plug those two numbers, 45 and 30, everywhere you see them in this identity right here. So it equals tan A, so that's tan 45, minus tan B, and that's 30. Suppose I should put in degrees all over here, over 1 plus tan A, that's tan 45, times tan B, which is tan 30. Wow, that looks more complicated than it was up here. Why do we do this? Because you actually know what tan 45, you know what tan 30 is, so we can simplify this. What's tan 45? Well, you got to look back at your unit circle, you got to do a memory device, and tan 45 we love, it's 1. Takeaway, tan 30 is root 3 over 3, or you might know it as 1 over root 3. I'll put it as 1 over root 3. You could also put root 3 over 3. It's actually kind of a better answer. On the bottom we have 1 plus tan 45 is 1 again, and we're multiplying that 1 times tan 30, which we already know is 1 over root 3. Okay, I'm running out of space, so I'm going to go over here now. Let's get common denominators here. So we're going to multiply, this is 1 over 1. We're going to multiply top and bottom by root 3. So we get root 3 minus 1 over root 3 on the top. And on the bottom, this is 1 plus 1 over root 3, right? 1 times anything that just stays the same. So again, let's get common denominator of root 3. Multiply top and bottom by root 3. You get root 3 plus 1 over root 3. Okay, next thing I'm going to do, I'm going to remind myself that this sign right here means divide. So I'm going to go root 3 minus 1 over root 3 divided by, but I'll multiply by the reciprocal. So root 3 over root 3 plus 1. You can cancel these out, but you can't cancel this out at all. This is a binomial, this is a binomial. They'd have to be exactly the same to cancel them out. So we're left with root 3 minus 1 over root 3 plus 1. But we don't want that answer. We want to rationalize the denominator. So we have to multiply top and bottom by the conjugate of root 3 plus 1. What's the conjugate? root 3 minus 1. Do the same here, root 3 minus 1. We're really running out of space, but we can get this done here. We do mountains on the top. So root 3 times root 3 is 3. Root 3 times negative 1 is negative root 3. And negative 1 times root 3 is another negative root 3. So you get negative 2 root 3. Negative 1 times negative 1 is plus 1. Over. Root 3 times, so we're doing mountains and valleys on the bottom too. Root 3 times root 3 is 3. Root 3 times negative 1 is negative root 3, and 1 times root 3 is positive root 3, so those cancel. That's always what happens when you multiply by the conjugate in the denominator. And 1 times negative 1 is negative 1. So what are we left with? Well, if we combine the 3 and the 1, you get 4 minus 2 root 3 over 2. You could simplify right now. If you don't know why you can simplify this, think of this. You could factor out a 2 on the top. So you get 2 times 2 minus root 3, right? Because 2 times 2 is 4, and 2 times root 3 is 2 root 3. That's over 2, and now you can cancel this out. This step was not necessary, but just in case you're confused about how you can go straight to canceling those three numbers. So you're left with 2 take away root 3. That's the exact answer for how much tan 15 is. Some calculators, if you put them into your calculator, they'll just give you that answer. So you might be sitting there giggling saying, hee, I can just put it in my calculator and it'll give me this answer. You'd be expected to show me the work, so I know you're actually doing this. Sorry. Alright, that took a lot of space. I know the second one doesn't take quite as much space. So hopefully we can fit in here. So the second one we're doing is cos 7 pi over 12. Now I'm just going to be honest about this. I really find this hard to do in radians, so I usually switch this into degrees. Remember how to do that? Multiply by 180 over pi. So your pi's cancel. 12 goes into 180 15 times, and 7 times 15 is 105 degrees. So basically, rather than figuring this out, because I find that really hard, I'm going to figure out the cosine of 105 degrees. You're clear this is exactly the same thing, right? This is in radians, this is in degrees. Okay, so I'm going to look at my list on the left here. How could I get 105 degrees? Because that's not a special angle. How could I get that from here? Well, I could do 135 take away 30. That would work. There's probably others you could do. You could do 60 plus 45. Let's do that. Since we did a difference last time, let's do a sum identity this time. But do whichever one you want. In fact, why don't you do the different one that I'm doing, and then you can convince yourself it'll always work. So I'm going to do cosine 60 degrees plus 45 degrees. Okay, so that is a cosine A plus B. Where's that? That is this one right here we're using. Alright, so that equals cosine of A is 60, so cosine 60 degrees, times cosine B, so cosine 45 degrees, minus sine of A, so sine 60 degrees, sine B, sine 45 degrees. Okay, now we go through it because we know all these. Cos 60, hey, it's a great one, that's 1/2. Think of your unit circle here. Cos 45, that's root 2 over 2, minus sine 60 is root 3 over 2. Sine 45 is root 2 over 2. Now we multiply. Multiply the numerators, you get root 2. Multiply the denominators, you get 4. Multiply the numerators, you get root 6. Multiply the denominators, you get 4. Hey, they got the same denominator. Why don't we put them both over 4? There you go. Exact answer. Okay, next question. Find the exact value of cosine of negative 10 divided by secant 35 plus sine 35 cosecant negative 10. Wow. So let's see what we can do here. Well, one thing I notice is in all these identities there's no secants, right? So why don't we get rid of this secant? How can we do that? Well, if we ignore the cosine negative 10, what we have here is 1 over the secant of 35. Well, what's 1 over secant? 1 over secant, the reciprocal of secant, is cosine 35. Oh, so really what we have here, since it's 1 over secant, we have cosine 35 degrees, then the cosine negative 10 degrees. By the way, it doesn't matter. You could have cosine negative 10 first as your A and cosine 35 as your B. It will still work. It doesn't matter. Plus, well, since we did the 35 degrees first here, let's do the 35 degrees first here. So sine 35 degrees. And again here, if it's cosecant, and I don't see cosecant up here anywhere, I don't want cosecant. What's cosecant the same as? Well, first of all, this is the reciprocal of cosecant. It's 1 over cosecant negative 10. But what's the reciprocal of cosecant? The reciprocal of cosecant is sine. So this equals sine negative 10. So we can rewrite this like that. Now, if you look, what we've written here is going to match the right-hand side of one of these identities. So we have a cos plus sine sine. Cos plus sine sine. There it is right there. So it's the same as cos bracket a minus b equals cos bracket a minus b. Alright, so it's the same as, what's our a value? The one that shows up first is 35. Minus, what's our b value? Negative 10. So it's the same as cosine of 45 degrees. These are all degrees. And we know what the cosine of 45 degrees. The cosine of 45 degrees is root 2 over 2. We're finished. Now, you could have figured that out from going through all this and taking your calculator and going, what's the cosine of negative 10, and dividing that by the secant of 35, which you can't even put secant in your calculator. You'd have to figure out what the reciprocal. I mean, it's really difficult, right? Instead, we did this work using the identity, and we know exactly the answer is root 2 over 2. That's the other thing. If you did all that with your calculator, you probably wouldn't even get an exact answer. You get a decimal answer. Given that sine A equals 3 over 5 is in quadrant 1, and secant B equals negative 13 over 5 is in quadrant 2, what's the value of cosine A plus B? Oh my. So, first of all, let's just draw the situation here. Sine A is in quadrant 1. So, we have this angle. It's in quadrant 1. The angle's called A. And sine of that angle, that's an A, sine of that angle is 3 over 5. Remember, sine is opposite, so opposite is 3, over hypotenuse. So the hypotenuse is 5. Now, guess what you're going to have to do here? You're going to have to figure out how much is this here. What's the adjacent side? So how do you do that? Pythagorean theorem. You go 5 squared minus, because you already have the biggest side, 3 squared equals, let's call it x squared. So that's 25 minus 9 equals x squared. 16 equals x squared. Take the square root of both sides, you get x equals 4. So this side's 4. Okay, the other thing it tells us that in quadrant 2, so we also have an angle in quadrant 2. It's called angle B. And it says that the secant is negative 13 over 5. So if you're good with secant, you can tell right away where the 13 goes and the 5 goes. I'm not so good with it, so I always remind myself secant is the reciprocal of cosine. So that means cosine must be negative 5 over 13. I'm much more comfortable with cosine. I know cosine means adjacent, so there's my 5, or negative 5 if you want. And the reciprocal has to be 13. Do the same thing to get this side. 13 squared minus 5 squared, or negative 5, won't make a difference, equals, I'll call it y squared this time. 169 take away 25 equals y squared. 144 equals y squared. Take the square root of both sides, you get y equals 12. So this side here is 12. Okay, what's the value of cosine A plus B? Well, we must be going to use the identities somehow, so let's go back and look. Cosine A plus B, it's the one we just used. We're actually going to use this again, so we should write that down. Cos A cos B, cos A cos B, minus sine A sine B. That's what the identity tells us. Now, why are we doing that? Because we don't know what the cosine of A plus B is, right? This angle plus this angle, and then take the cosine? I have no idea. I don't even know how much that angle is. But we do know all this information, or we've kind of figured it out now. What's cosine of A? Well, the cosine of A is the adjacent over the hypotenuse of this angle. Well, that's 4 over 5, right? 4 over 5. So cosine A is 4 over 5. Cosine B, well, you can either look here and say cosine B is negative 5 over 13, but remember, we already figured that out up here too. So double the reason to suggest we got that right. Sine A, you can either look here and say sine is 3 over 5, opposite over hypotenuse, or it just tells us right there sine A is 3 over 5, so feeling pretty good about that. Sine B, you got to use your little graph here, a little picture. Sine B is opposite over hypotenuse, that's 12 over 13. Now we're ready to multiply. 4 times negative 5 is negative 20. 5 times 13 is 65. takeaway, 3 times 12 is 36, 5 times 13 is 65. We already have our common denominators. Negative 20 take away 36 is negative 56. Common denominator stays the same. Negative 56 over 65 is our answer. Okay, we're going to solve an equation that looks like this. Sine 5x cos 3x minus cos 5x sine 3x equals 1. Wow, it looks so difficult, don't know what to do. But it's not so hard when you realize that this highlighted part on the left-hand side is exactly one of the identities. So we have a sine cos minus cosine. Sine cos minus cosine. Where is that? Sine cos minus cosine. There it is. Whoops. Highlight. So that means it equals sine a minus b. So we can rewrite this as sine a minus b. What's a in this case? I'll just write them out here to make sure you're clear. It's a is 5x, b is 3x. So we can write this as sine 5x minus 3x. That takes care of that whole highlighted part, equals 1. Well, 5x minus 3x is no problem. That equals 2x equals 1. Okay, this is kind of like what we did last time. If the sine of some amount equals 1, well, you know when sine equals 1. Sine equals 1 when x is, or when the angle is, sine equals 1 when the angle is pi over 2, 90 degrees. Is that what x equals? No, that's what 2x equals. This is one of these ones. 2x equals. So if 2x equals pi over 2, then x equals, well, divide both sides by 2, you get pi over 4. Okay, careful before you stop here. We need to make sure we get all of the angles between 0 and 2 pi. So remember how you can get the next one? You can think to yourself, what's the period in this case? So if you look here, this is what we end up solving. If you look here, the period equals 2 pi over b, and the b value is 2. So it's 2 pi over 2, which equals pi. That's the period right there. So if you want to get the next value that works, you would take the original value, pi over 4, and you would add pi. Pi is the same as 4 pi over 4 plus this 1 pi over 4 equals 5 pi over 4. Let's say you're not sure whether that's it or not. Maybe you think there's another answer. How would you get the next one? You'd take 5 pi over 4 and you'd add another period of pi. That's 4 pi over 4 plus 5 pi over 4 is 9 pi over 4. Is it too big? Yes or no? Remember, it has to be smaller than 2 pi. 2 pi is the same as 8 pi over 4. This is 9 pi over 4. This is too big. So our answers are x equals pi over 4 and 5 pi over 4. Okay, find the amplitude, period, and phase shift for y equals 5 sine blah 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 blah. Wow. So we want to know the amplitude, period, and phase shift of that. That doesn't look even close to our form we need it to be in. Remember, we need it to be in y equals a sine or cos, one or the other. We got both of them in this case. B, x minus c plus d, and instead we have this. How are we going to do this? Okay, if you look at this though, you can see you have a sine minus cos. You also have the 5 up front, but just ignore that for a second. Sine minus cos. Do we have an identity that says sine minus cos? No, we don't. Oh, darn. But we do have a cos minus sine. How could we turn our sine minus cos into a cos minus sine? We want the things to be the opposite signs. So why don't we factor out a negative? If we factor out a negative, this would then become negative 5 sine blah blah blah. This would then become positive 5 cos. And we could just write this first once it's positive. Another thing you need to factor out is the 5. We don't want this 5 sitting in there. So what we're going to do is we're going to factor out negative 5. I want you to look at this part first, the second part. I'll highlight it. Look at this part first. If we factored out a negative 5 there, what would you be left with? You'd be left with positive cosine pi over 3x cosine pi over 4. Then if we look at this part, negative 5 times what equals 5? Negative 1 sine pi over 3 x sine pi over 4. If I did that too fast, then what you should do is factor out a negative 5 and keep it in this order, and then you'll see you can switch the order around to have the cosine first and the sine second. Okay, so now we have a cos minus sine, and we already said that does exist. cos minus sine is the same as cos a plus b. So we can rewrite this as y equals -5 cos a plus b. So that's pi over 3x plus, what's the b value? Pi over 4. We're getting very close to getting it in this form. We have our a value, we have our cos. We don't have that x by itself. We need to get the x by itself. So this pi over 3 needs to factor out into the front here. So you get y equals -5 cosine. Factor out the pi over 3. That leaves you with x here. However, you also need to figure out what's the new value in here. Since you're factoring pi over 3 to the first term, you have to also factor to the second term. How do we do that? Divide that pi over 4, divide it by the pi over 3 that you took out. That's the same as pi over 4 times 3 over pi. Whoops, 3 over pi. And then you can cross these pi's out. You get 3 over 4. So x plus 3 over 4. Okay, we're ready to answer this. Amplitude. Amplitude is equal to the absolute value of a, and the a value is -5. So it equals 5. The period, for cosine and sine, remember it's 2 pi over b. For tan, it's pi over b, but this is a absolute value of b. This is a cosine, so you're going to use 2 pi over b. So it's 2 pi over, what's our b value? Pi over 3. So that's the same as 2 pi over 1 divided by pi over 3, but I'll flip it, multiply, so I get 3 over pi, and we end up canceling out those pi's. So you get 2 times 3, you get a period of 6. And the phase shift, that's our c value, right? The phase shift is plus 3 over 4, so the phase shift is -3 over 4. In other words, it's going to move 3/4 of a unit to the left. There's your answers, 5, 6, and -3/4. All right, we'll continue with this next day. I figured that's enough to keep you busy for today. Some of these questions are quite hard.